Hello everyone, my name is Steve. I want to welcome you to my YouTube channel. You'll see Commodore 64, Atari, 8-bit computer content on this channel available. Mostly there's a lot of tutorials for basic and assembly language. And what this session is doing here is just kind of continuing off where we left off last time. I was teaching you guys how to redefine your own character set, which basically just changes the characters in the background here. And I promised you guys I would start working on a game. And as you can see that here, we've already got a screen set up here, so I'm kind of moving that along as quickly as I can here. Now the game's not totally complete yet, there's still some flaws in it, but I'll kind of demonstrate what I do have done on it so far, and then kind of explain how it works and how you can kind of start your own stuff. And you've probably noticed when I'm moving here, that's one of the flaws already. So now first of all, he can go from side to side just like he did in the other ones. But if I move this way, the frame is messed up, and the reason why is the frame starts at memory location 832 and goes all the way up into screen memory. So basically what it's doing is it's looking up here, you'll see the box here, and it's replacing what's up here in screen memory, and that's why the sprite is looking like a box basically. Now the only way to do that is to move memory back, move basic memory back so that it doesn't run into the screen memory. I haven't done that yet. I haven't had any success with that actually yet, so I'll do that in probably another example here. I just wanted to get something out so you guys can kind of see where I'm at and didn't think that it was delaying you for too long here. So what I do have going on here, you'll see that little thing that says COLIS. That's for collision. So basically it's saying whenever he touches something like the ladder or anything that's in the way, you'll see it changes to a 1. Now when that's happening, he's going to be able to move up and down. I'll show you. So I can get him to go up the ladder there. Now he's at the top. Kind of move around and walk him around here. Just to show you, everything else is still the same here. And until he gets to the ladder, oh yeah, actually there was an error there. I still need to fix that. That's because the collision is not clearing here, so he can still technically move down even though he's not on the ladder here. Later I'm going to have it, once I have it collision set, he'll only be able to go up and down the ladders. But the problem is the collision itself is only being reset down here, so I need to fix it up here too. I just realized that. So he gets up here, the collision is still on. That's why you have to clear collisions. If you don't, then you're going to have all kinds of funny stuff happening. Now the only other thing is he can't go down this ladder, and that's because I have this variable set up in the program to only move up and down this ladder so far. I haven't really programmed the other one, so I just wanted to kind of show you where it was at, and that's kind of the progress I've made thus far. So let me go ahead and stop the program here, and we'll look at the code, and I'll kind of explain that to you. Go into the listing here. Now this is again very similar to the character set demo, so everything is going to be kind of taken off from where that left off at. So this obviously is just changing the color of the border. This is the screen, or sorry, this is the screen right here. These are the multicolored characters that change the sprite. So if you just type in, notice this one says a 2 here. If I type in poke 646, 2, you'll see it's like an orange, and that's like for the player's face, I believe. And then the other one, I just moved it off the screen here. Go back there here. So I type post 646, 3. For this one, you'll see that this changes to like an orange, or excuse me, a green, which is part of the player. I forget what part it is, but it's. I could probably poke him on the screen here. We might be able to see it. Let's see. He's hiding somewhere here on the screen. I have to turn him on too. Oh well. Well, anyways, let me just we'll get back to that here a little bit. I was just kind of trying to show you what's going on with the character and everything there. So, what happened here? I think the color turned off. Okay, so here we go. So, where we left off at here is this is actually doing the same thing as a character set. So this is redefining the character set here. DT poke 49152 plus X is reading in memory location 49152 up to 57 bytes in there, so it can store in the data statements. Now, for those who were probably confused on the other one, that's basically all it's doing is reading in this data right here. The 0 is 169, 0, 141, and this is the assembly language that you guys have probably seen in my Atari videos if you've been following those. And if you're not, I would probably recommend to even look at those videos. Now, if you want to see the explanation, I do have this taken down here further in the code. So if you probably just want to remember this, the 169, 0, 141, up to this line right here where it says 2896. I'll show you, I'll show you down here where that is. We'll kind of jump around here a little bit, but I have it down underneath here. So right here where it says Redefine Character Set, these are the same data statements that you just looked at, and this will break it up line by line basically. Now, I don't think I really explained that a whole lot because it's not more necessary understanding it, just knowing that if you use this data statement, it'll redefine the character set. And all this is doing right here is just taking the high and the low byte memory so it can move the RAM, the ROM to RAM, because your character set is stored in ROM, read-only memory, which means you can't, read-only memory, which means you can't write over it, but you have to move it to RAM, which is known as random access memory, so that you can write over it. The reason why they did that is otherwise you would be able to write over the characters, and other parts of the programs and routines would be able to write over the characters and would kind of, flaw the design of BASIC. So they made it that a little bit easier to do it that way. These are just moving into bytes right here, into the high and the low bytes. I hope I don't have to go and explain all this to people, because like I said, if you really want to learn assembly language, just watch the other videos I have here on the assembly language. I do go in and explain the high and the low bytes a little bit better. Make sure you're following all those along very carefully, and this won't be too complicated. That's all this is doing. Is just taking the high byte from 253, to explain this right here, you just will probably require some explanation. So this load accumulator 253 is taking the high byte of whatever, or the low byte, I'm always saying the high byte, the low byte of what's in 253, which would actually, this line right here is representing the, I believe this is the ROM. Yeah, the ROM, because it's picking up all the memory in ROM, and this is the RAM. It's going to store into the high and the low byte in the RAM. So basically that's where it's pointing to, into the character set. So if you want to see another video or another example here, I do have this I could pull up in, where is it at here? I got to pick the wrong one. Right here. And this kind of explains the character set a little bit better. So you'll probably want to, let me show you which PDF this is, by the way. This is programming graphics on the Commodore 64. I'll provide a link into my description so that you can go ahead and read through it. But this will explain how the character sets work for those who wanted to know more about what do the addresses do and all that. It's right in here. So this one basically just takes you step by step what basically is going on here. And you'll understand a little bit better of how it works. And this is basically all I'm doing here is the same thing that's I'm duplicating what's going on over here, except I'm doing it in assembly language. So they're doing it in BASIC here, obviously. You want to do it in assembly language though, because it's faster. I mean, you can move ROM into RAM in BASIC. It just takes a little bit longer, and I don't like the delays and waiting every time. So I like to speed everything up, so I just put everything in assembly language, since that's what I'm used to. So now I did explain this in the other videos, but this is a new line and I wanted to explain this. This F equals 60 to 63 plus 29. This is reading in the bytes from 60 up to 63 plus 29. So all the characters in the memory are going to be read here. Remember, this is just reading in the random access characters so that you can start overriding the data. An important thing here is you'll notice it says for x equals 0 to 7. And then over here it says read A. So it's going to read a data statement down here, and I'll show you in a little bit. And it's going to poke it into 122.88, which is a safe place to store it in memory, because this is where we basically, the assembly language program moved it. It moved it, all the ROM characters and everything you see from A, B, C, D, and all the other characters that exist on your keyboard as you type them. they got moved into here so that you can start, creating them and changing them to what you want them to look like. And then this 8 is just representing that there's going to be 8 in length. And this times F is just picking up all this stuff right here. Basically, it's just going through the for loop here. And then added to the X here is just adding in each individual data statement. That's all it's basically doing. It's just reading all the way through. And let me show you. Now you notice I remarked all these out before because this kind of breaks it down step by step. And this is originally how I did it, but I wanted to shortcut it and do it this way. But basically that's all it's doing is this would be one character redefined. This would be a second character redefined. Another character redefined. For example, this could be like a brick wall. This might be the ladder. Whatever it's pointing to in the AXI character set. Now, I don't know if I have any way to show you what the AXI character set is here. Let me see if it's actually in my book here for a second. For those who really want to understand, from a different perspective. I didn't come prepared to think about this one, but let's see here. I have an AXI character set here, but it isn't exactly the right one. This one is actually just showing the printed AXI characters, but we want to be able to see the screen codes, and I think I just found it. Yeah, I did. Okay, so let me pull this up and show this to you. Hopefully you'll be able to see this. Okay, so before we go on, this is obviously the reference we've always been using now for the Commodore 64. I really hate to bend this book, but that's probably the only way I can really do it. Let me see if I can get it to go back. I'll just kind of hold it there. I don't want to mess it up a lot. But basically what you're looking at here is the screen codes in memory. Okay. Camera's going to have to kind of twist it a little bit there because it kind of bended. So you see how these codes right here? These are just poking in each individual one. So like the first one could be A, and you would redefine A to be whatever you want it to be, B, C, D, and so on. I skipped down to 60 so we would skip over the alphabet because I didn't want to erase the alphabet since you use that for writing and stuff like that. So I made it jump way down here, even under the other characters and stuff like that. So basically it's down here. I made it start at the little, the less than character. So I had it start there basically. And that's what you see going on over here when you're looking at the screen here and you're seeing the 60 plus 63 plus 29. That's what it's basically starting at, is the 60th AXI character set. So it doesn't overwrite the letters. Okay, so let's go back through the listing here. And I wanted to show you the data statements for this. Like I said, this is just piggybacking off of the original Redefine Character Set video I put up on the last example. So right here, remember when you saw earlier where it says X? Let me pull that back up so we can show that side by side here. So line 45 is what we need. Let me get back to the data statements here. Okay, so we'll type in down here list 45 so we can keep it on the screen here. You see where it says for X equals 0 to 7, that's just counting right here. 0, 1, 2, 3, 4, 5, 6, 7. So it's reading in 7 characters there. That's why you put it X equals 0 to 7. Read A is going to read the first one here when it starts off first. It's going to read the 0. And then it's going to take it and move it into this memory location so that we can start changing it. 12288 plus 8 times F plus X. You saw all that earlier. And then that's just basically going to go through all of them. That's what the F is doing. It's going through all these down. And this is just kind of go through them crossways. So as long as you do it that way and you specify, was it at 40? As long as you specify in this line, oh, I got the wrong line here. It's 42. Right here, as long as you specify in this line how many characters you want, it's going to know where to start right here and where you want to end. If you only want to do a couple, you would just do like 60 to 63 or something like that. You would need to do the plus 29. That's just because I'm redefining a bunch of them here. So let me go back here again. This is a pretty long program, I know. Anytime you design games, they're going to be long though. Okay, so let me pull those up here. Okay, so you get the idea there, so hopefully you do. That's just poking in 122.88. If you look at it this way, it's 122.88, 122.89, 122.90, 122.91, 122.92, and so on. You're just basically counting through them. And remember, this loop right here is just keeping track of how many down here you're going to have. So basically, I have this many in rows. So if you take the 63 plus 29, I could show you here. So print 63 plus 29, which is 92. Remember, we started at 60, so you would take the 92 and subtract it from 60 to tell you the total. So there's 32 I redefined, basically. This tells me I have 32 data statement lines here that's going to read in all the character sets in memory. Now, I won't go in there and show you how to redefine these exactly. You'll want to watch the redefine video because it does explain step by step on even on graph paper how that's actually done. I had to provide that again because I noticed I only did originally for the Atari and it wasn't fair for the Commodore people, so, or the Commodore fan group, whatever we want to call ourselves here. And if you count all these down here, there'll be 32 lines of these. So, okay, so we should be okay on that now. This stuff is going to draw the screen. You saw earlier the ladders, you saw the sky being drawn and all that. Right here, this is just drawing in everything. 1024 represents the screen memory. I did explain this before, but 1024 starts up here, and it just starts counting over. Each line is going to be 40 in length, and just keeps going down here. So basically, this first line here is the same for a equals 0 to 40 times 11. So it's basically, the easiest way to say it is going to pick up the top line here at 1024, and it's going to put in the color code. This is for the color code. You always add the 54272 to get the color, screen color memory for that character. If you don't, then it's only going to be in one color. And then what this is going to do is going to draw all, you saw that lines being drawn across the screen earlier. That's basically what that does, is draws that green sky that was going down the screen there. And that's why I have times 11, so that it's going to pick up the next line. Because remember, they're 40 in length, so if you multiply them by 11, it's going down 11 lines there, basically. Okay, so this next one is the positioning for the score. Right here you see this S in this Q. This S is basically a symbol for the home. So if you're used to the Commodore, the easiest way to do it is print like this. You just hit I think you just hit the home key if I'm not mistaken here. Yeah, and it prints the S. So that's going to basically position the cursor way up here at the top so that you can position the text where you want it. And then if you want to do down, you just hit the down arrow key there. And watch what will happen. I'll show you. See, it moved it up here. Basically, it moved it up here and it moved it down. We also inserted the ready prompt, but it would have, normally done it correctly here. So let me go back in here. Okay, so that's what that does, and this just turns on the color white. So you saw the score earlier in the white color. And basically, this is tabbing over 4 spaces, and it's going to print the score. You saw it kind of over there in the corner. And then it's going to tab over 6 more, and it's going to show the lives. And that's to set up the variable for the lives. And this one down here is just the next positioning, except this one's positioning in the collision message here. So this right here, this 92, this is, I need to look this up in my character codes here, but this is actually the brick wall. So it's just basically going to, when you saw those walls being drawn on the screen after we drew the sky, that's basically all it's doing is right there. It's just picking up screen code memory 1464, and it's going to start drawing in all these walls. So A equals 0 to 39, so 1464 plus A, first time it's going to be 1464. The second time, 1465, 1466, and so on. And that's how you see the lines being drawn across the screen, basically. If you want to see that, I could even show you that real time here. We could just execute that line by itself. Of course, it's not going to be a redefined character, so you won't see what it looks like, but I'll kind of show you if I take it off here. You'll see it draw something across the screen there, right there. That's basically all it's doing in it. And of course, once you redefine that, it would turn into the wall. So you see where it kind of drew it at? That's at line 1464 there. So if you count 1024 down to here, that's where that begins at. So and that's what you have to do is you have to kind of calculate where the drawing is going to position at on the screen to draw with the screen memory. Now it is kind of slow when you draw in Basic. For those who prefer to learn that way, you can, but later I'm going to change it to assembly so it's a little bit faster. So our game is more, realistic and just easier. Just it runs easier and easier to play and stuff like that. But I did want to show at least this for now, so that people who don't know how to do screen drawing in memory will learn how to do it. I showed this in the other one, I believe so I'm going to show you again though. So if I type in poke 1024 plus 33, look up in the corner here, you see the exclamation mark. Now earlier we said the other one was going to start at the 1, that's going to represent the A. Remember the Atari character set I showed you earlier in the book? And then you take the screen memory, you just take the 1024 and you add 54272 to it, and then that will change the color of it. So wherever it's at, if you put it at 25, you want to make sure you change this to 25 and just change the color again. And now you got a different color for the next one. That's basically all you're doing. Well, we had the same character. I'm going to change to the C or something like that. So, oh, the 6, that's the blue. You won't see that one because it's matching the background. So put the 7, I think that's the yellow. There you go. Now you saw the yellow appear this time. So, okay. So if you have any examples of these, just run them by themselves and you can kind of see what they do. This one, of course, is on 2 lines, so you probably won't be able to see this one run unless we typed it all out or something. But this right here, to go back to my example, I have a little sheet I'm looking at to refer here so I know which redefined characters are being redefined. So, the way it works here is 92 is the wall. I did show you that one. And then it draws the 2 different walls, the one on the top and the one on the bottom. The 89 is that little thing you saw at the bottom there for the item, whatever the item's going to become later. The 92, those are the brick walls. Right here, this is drawing the brick walls across the screen. I'm looking for the ladder. Okay, the 90s are the ladders. These are the ones that's drawing it down. Notice I have 40 times A. So if you take that line, it's basically drawing down the screen. And I'll just show you on that one line alone. We'll run it in immediate mode again so you can kind of get an idea. I'll need to add the next on here because it's on the next line otherwise. And you'll see what happens. See how I drew it down the screen? If you want to change the character, you just go in here and you just change whatever this is, and it'll change the character like that. So, kind of play with those, and you can kind of learn how to position them. If you want to make it go higher up on the screen, just change this number to something else, like 1410 or something, and you see how it moved up a little bit more. And then you would want to make this line here longer, and you can make it go farther down the screen there. We don't want to go too far; it's going to end up messing up our program. So. But I just wanted to show you how that works and everything. Alright, what happened here? I think I might have just messed it up. Oh my gosh. I just dropped my camera here, so let me pull my camera back up. It's the first time that ever happened. Something is wrong with the program. I notice I can't seem to reset it now for some reason. I don't know what happened to it, but I should still be able to list it, I hope. That's because I drew too far down in screen memory. It was exactly what I was telling you not to do is what I did. And I screwed it up doing such a thing. So let me see if I can just reset it from here, hopefully. Hopefully I don't lose it that way. Yeah, I knew I was going to lose it. maybe I'll do another example on screen memory later, but I don't really have a whole lot of time to really show you here. Remember, 1024 is the top. Right, type it in right. 1024 is the top line there, and then the bottom one might be something like 19 or something like that. Let's see where 1924 falls at. That's pretty close. So if we go down a little bit further, it's like 2010 or something maybe. 2020. It's 24. Or 23 maybe. It's 23. So 2023 is the very bottom corner. So earlier when I drew that line, I went too far and it kind of overrided and locked the program up. So I couldn't do anything else with it. So let's get back to the program here. Kind of where we left off at here. Where were we? Well, I skipped down to show you the data statements, but in between here, these are just the print statements. These are going to print out, actually these were for the original redefined characters. So I'm not using these ones anymore. I kind of jumped over these ones, so we're not going to mess with that here. I could take that out. It's not going to affect anything. Just like all these lines are remarked out, I just need to remove those later. I just had them in for, demonstration purposes. So here's where we left off at. So we got the characters redefined and everything. And then we're going to go into the core here. I showed you kind of all this stuff already. So let me go down here. This is just positioning more of the screen codes in memory, screen characters. This gets into the heart of the program right here where you see this px equals 154. This is representing the player's x position and this is the player's y position. So he's at 154, he starts over at 154 and he gets moved down to line 165. So that's how you get in position on the screen. And these right down here poke into 53,248, whatever's in px 154, 53,249, 165, and that's how they get positioned there. Okay, so this MV, this is going to represent the movement of the up and down ladder. Right down here, you'll notice this, I need to explain a few other things before we go there. This JO is keeping track of the joystick. So this JY equals peak is reading into the joystick location, and this is just converting the bits, so that we know which bit is being set. So bit 4 is being set. Let me see, bit 4 is being set, that means he's moving backward. If bit 8 is being set by the joystick, then he's moving forward. And down here, see, if bit 1 is set, he's moving up, because you notice this is -1. Otherwise, 2 is down, +8. And it's the PY is representing the vertical, and the PX represents the horizontal. Well, actually, it goes into this 4200. I could go there. And like I said, if you watch the other video, it explains that one a lot. And I'm talking about the one with the animation in it. I'll put the link in it so that you know which video that is here. This right here is just showing the PX movement across the screen, and I did explain that in the other video. So it's going to be a little bit more difficult to try to keep going through it and say, go back and refer this video. So make sure you're watching them in sequence, and it's that much easier to follow kind of where we left off, because I'm going to kind of append everything together so we keep building this game and keep moving it forward. And this right here, this poke 214, 3, this is just positioning the cursor. So it's going to position it 3 lines down and over 20. And then that's how it gets that. This is the collision that you saw earlier being printed on the screen. So when he's running into a ladder or something, it's showing that 1 or the 0 is on or off, basically. This is for the frame animation of the animation character. Because remember, this is just that animation video I put up for the character moving across the screen. If you watch that, it'll explain a lot of this in here. But I'll go into detail about the stuff that you may not, that is actually new here. So, which includes the movement, of course, up and down the ladder, which is right here. So as I was saying earlier, that bit 1 is set. That means he's moving up. CS, let's go back here a few lines because I know I kind of jumped ahead here. So I can show you what CS is. Right here, CS is reading in location 53, 249, so it's peeking into this location to see is there a collision going on. So this is where you saw the 0 and the 1 up on the screen earlier. That's why I positioned to show it to you, and also so that I could check it myself to make sure it's being detected. And this is right here is going to say the 0 or 1 depending on whether he's touching a character or not. And that's how we make him basically say, okay, touch the ladder, now we need to do something. And that's the next step here I wanted to show you, where I just was earlier. Right here. So he's moving up. CS means yes, a collision was set. So now 53,249 through 53,279 is set to 1. And we're going to start this and locate and check this variable called NV, which is the movement. So right here it says that the movement is less than 6. Then we're going to keep incrementing the vertical location of the player, which means he's going to be able to move up. So PY is being poked down here. This is V plus 1 is representing 53,249 memory location, because the V is actually equal to 53,248. It's up here in the program though. And this is just poking in the horizontal, and this is the vertical. Just remember that this is the horizontal, the V plus 1 is the vertical. So it's saying right here if NV is less than 6, and earlier up here in the program, let me show you that again if you don't recall it. Right here we set NV to 0. So the first time we're going through and we're going to try to go up the ladder, NV is not less than 6 because it's still at 0. So it's still going to execute this line because until it's less, well I'm sorry, let's see, less than 6. It's at 0. Oh no, I'm sorry, it's going to probably see less than, no, it's going to work because NV is still, excuse me, less than 6. NV is 0, so that means this line's going to be true. And that's going to allow him to move up and down. Now what we do to make sure it doesn't go all the way off the screen as you start moving is check how far he's going to move. So if you increment NV right here, NV equals NV plus 1. So once you do this, it's not going to be equal to 1. It's going to go back here and check this, less than 6. It's not, so go back here, move the player up again, and then increment NV again, and keep doing this until suddenly NV is at 6, and the player has already moved up 8 each incremented bytes. So that keeps him going up and down the ladder up to a certain pace and back down. And that's what this next line does. The JO equals 2, the joystick equals 2, bit 2. And the collision is on. NV is greater than 0 because now we're going to move him back down. So if we moved him up the first time, remember NV equals NV plus 1, it'll get to 6. So when he moves up to the top of the screen, NV is now equal to 6. So now that NV is equal to 6, we're going to be able to move him down. So we're keeping track of this own NV that's basically going on. So I don't know, this is just one way I found out of doing it. Kind of similar to something I did before. So now he's at the top of the ladder. NV is equal to 6. Is NV greater than 0? Yes, it is. NV is now at 6 because we moved him at the top of the ladder. Then now we're going to be able to safely move him down. So that's what this one is doing. It's moving him down. And notice this one incremented NV. This one is going to subtract from it because now we're going to move him down. We're going to keep track of NV going down. And that's basically how I tricked the computer into making him going up and down the ladders, basically. This is supposed to clear the collision, but it's not working, so I need to check into that more later. This is where I do have it clearing the collision if nothing else is going on. I was trying to get it to clear, like I said, and I just couldn't get it to work, so it only seems to work though once he's down the ladder, so I think it's only probably checking these lines and probably not checking this one or something. I don't know, but just something to look into. NV is greater than 6, so remember NV greater than 6 means he's already at the top of the ladder. Then again, I was trying to clear the collision here, but it just didn't work. Go to 1060, it's just going to go back to 1060, so it keeps the joystick in the loop so you can keep moving the player and everything basically. I'll try to explain that more in the comments because I know that's going to be probably hard to follow, how the movement goes up and down the ladder. But just think of it, just keeping track of how many places he's moving up and down. That's basically all I did here. Okay, what I was explaining earlier, to get back when we ran the program, you saw me moving the character and you saw that little box coming up. Remember I said it was picking up the screen memory? Now if you look here, I have it poking in from 832. This is going to be the first animation frame for the man with the hat, or whatever you want to call our game character. This is going to be the second animation frame, third, fourth, and so on. Eventually what happens if you start at 832 and try to, without moving basic back, it's going to run into screen memory, because remember screen memory starts at 1024. So right here it's already running into screen memory. So by the time he gets to that frame, he's already reading what's on the screen there. So that's why the bytes were showing that whole square, because in screen memory originally we had drawn and basically blocked out the top here to create the sky, and it's just reading in what was there basically. So something I need to fix for sure. Okay, this is just a shortcut to initialize 53248. Remember that's the horizontal position. The V plus 21 comma 1, I believe that's the enable sprites. The V plus 39 comma 1, I don't really have all these memorized without looking them up here. I'm so tired as it is, so I'm not going to be able to continue very much longer. But if you take 53248, add 21 to it, it'll tell you what this one is, 39, and so on, basically. Okay, so this one, V plus 28, comma 255. You can also do this. I showed this in the other one, but you can just basically do that. Oh, I forgot, I got to set V again. So V equals 53. Excuse me. V equals 53248. That's where we start the VIC memory at, and you just basically add that one to it, and now it'll show you what the memory address is for. And what happened here? I put an asterisk in there. So 53276. So if I go through the favorite map of the Commodore 64, we could look that up and try to see what that is. Before I end up falling asleep here. I'm so tired. It took me a long time to really get this thing as far as I did, so I was spending many hours trying to get it to work correctly. Okay, so it says Sprite Multicolor Registers. That's just basically taking care of the multicolor. That's all that's for right there. So I did explain this one the other one, but this right here is reading in the data statements right here where it says right here, for x equals 0 to 62, read B, poke 896 plus x comma B, all the way up to 1280. That's just reading in all the sprite data. But like I said, once it gets down here, it's also colliding with screen memory. So it's not any, it's basically reserved memory. You can't write over screen memory or it's going to start showing up on the screen. And let me run that right now and show you what I mean. So I'll stop it as it's running to show you where it's at. It'll draw in a second here. Okay, all that garbage right there you're seeing, that's actually reading into sprite data. Now this is stopped at 66028. We go there, you'll see right there, it's reading in 1216 plus x comma b, which is screen memory. But I was trying to get the frames to read in somewhere so that we can go ahead and animate them, but right now I still need to play with that so I can get that to work properly. It's only because we have the sprites and the character set in the same program, so it's taking up a lot of memory there. So, but if you move it back, it's obviously not going to make the frames run into anything else. Commodore has a way to move memory back and kind of do all kinds of stuff with it, so that you can do more with it, basically. Let's see what else is in here. Okay, I think that's about it. Yeah, that's just all the sprite data there, basically. So, run it again here. I can't stay awake very much longer anyway, so. It's already like 4:17 a.m. here, so that's too much for me. But I wanted to put something out there so I could show it to you. Oh. Okay, so that's where it's drawn in the sky. Remember, this is just a screen memories drawing. So now it's drawn in. You saw earlier that on the screen it's drawn in that line there for the wall. And then there's the ladders for the 40 times 11, because it's going to be basically 11 in height there. And that's that character, which I needed to move that up here, but that's basically it. So for right now, that's all it's been designed here. So let me go back and check the program to make sure if I try to address any other questions that people are going to be asking me. I think that's just about it here. So there's really not a whole lot more I can really explain. Everything else I'll probably just throw into the comments. This is just repeats of the other programs, so I didn't want to go back and tell you all this, but this is just keeping track of how far he's moving across the screen before he flips that most significant byte. Excuse me, I'm so tired here. Okay, so that's pretty much it right there. There's really nothing else in the program out of what I've already been showing you. So hopefully you can get something out of this. I'll put this D64 file on my website once again so that you can go ahead and download them and kind of learn from them that way, because a lot of people do prefer to do that. But yeah, it's late and I'm gonna head out of here. I just wanted to get this video up for the night, and I'll try to get a better one when I'm actually awake. So thanks for watching, guys, though, and if you're interested, definitely go ahead and subscribe. I'll keep getting videos out here as fast as I can get them, as fast as possible. Have a good one. Actually, I tried to stop the camera here. I meant to stop Camtasia. That's how tired I am right now. So anyways, here we go. Have a good one.